So sorry for interrupting the moments due to loss of connection.
Beautiful organizer, Dr.Wah Wah Min, is now the beautiful speaker, going to speak on the beautiful marine organisms crab species. Dr. Wah Wah Min is lecturer, Department of Zoology, Make University, Myanmar. Zoology teacher, researcher in Myanmar, 18 years of teaching and research experience, presently working as postdoctoral fellow of the World Academy of Science Italy and Government of India. She executed 2 research projects funded by Government of Myanmar. She is now IUCN Specialist Group member for horseshoe crabs and also National Advisory Committee member in Forestry Department for Conservation on Coastal Resources in Myanmar. She attended UNU UNESCO International Training course on mangrove biodiversity and ecosystems in India in 2015. She was a visiting scholar, Veilaka University, Thailand in 2017 and 2018. She attended Asian Mangrove Congress at Philippines in 2017 and also the second international conference on environmental and energy engineering, China in 2018, and fourth international workshop on science and the conservation of horseshoe crabs in China again in 2019. She has 7 publications to her credit. She visited India, Thailand, Philippines, China. So may I call upon ever smiling Dr. Wah Wah Min to speak about the beautiful organism crabs in mangrove ecosystems.
Hello, good morning, all of you. Today, I would like to talk about on crabs in mangrove ecosystem. So, scientists are telling crabs are key strong species of mangrove ecosystem. Why? Because crabs are playing a vital role in structure and functions of mangroves and increasing growth productivity of mangrove ecosystem. And then some crabs are adapted to harsh conditions with morphological and physiological and reproductive modification, and then maintaining low body temperature and varying tree climbing, air breathing, and flexible feeding habitats. So this figure shows the global distributions of mangrove crabs, especially mangrove crabs are distributed in tropical and one temperate latitudes lying between 32 degrees north and 38 degrees south into global hemisphere. The Atlantic, East, West, South America, and West Africa, and then Indo-Pacific, including East Africa, and then Middle East, and then the Southeast Asia, and then East Asia, and the Australia. So that this table shows the country-wide distributions of mangrove crabs. So you can see this table. India has the highest number of mangrove crab species, but less area of mangrove hedges, mangrove forest area compared to Indonesia. Like you can see, Indonesia has the highest mangrove forest area with less number of mangrove crab species. Why? Because in India, most of the species are already conserved. So that's why species diversity is more and more. And then mangrove plantation also higher. So that's why crabs are so much diverse in area. And then the total mangrove crab species in the world is 369 species. The biodiversity of crabs increases with mangrove cover, not explored for a comprehensive checklist of crabs in mangrove of different countries and more. So we can find that is 5 families of mangrove crabs that we can find. That is grapsids, and then oxypotics and porcunics, and then the xanthics, and then decasinics crabs that we can see in mangrove area, especially sesamics have attained extreme diversity and richness in Indo-Pacific mangroves. So morphology of crab is very important for identification. Especially crab identification is there. That is especially on we emphasize, and then we focus on that is identification is on carapace, shape of carapace, and then the kilip. This kilip also very important for identification. And then another thing is in this crab see that you can see lateral lateral spine can available, and then walking leg. See, this crab is in fifth walking legs, that is sorry, swimming legs. This swimming legs are like paddle shape, so we can easily identify. So now, we ensure the aggressive crabs. The character of aggressive crab is rectangular carapace, and then eye strokes of brown with cream, dorsal longitudinal stripes, and then the corneal black color, and then walking legs, little flat, and then the moderate broad. So that's for sesame crabs. And then family Gracidae, that's a mangrove crabs. Gracidae is a dominant crab species in the mangrove. And then over 100 species in 29 genera, known as the marsh crabs, the shore crabs, the talon crabs, are the living beneath reef in the high tide mark in the estuaries and lagoons. See, these crabs are climbing on the tree. And then tree climbing crab, that is a sesame crab, because these crabs are sharp tips at the end of their legs. So these crabs can escape from the predators, and then they are climbing on the tree, so they can avoid the height that is coming, and then hot temperature also that they can avoid. And then another one is oxypodic crabs. Oxypodic crab is key character is especially carapace is more or less square, and then in the middle, one kilip usually right sides, and then the much larger than the other, large claw horizontally wave, and that comparison to the fiddle and a bow. So that's why these crabs are called the fiddler crabs. 45 species in 10 genera, and then include ghost crab and fiddler crabs. So family oxypodidal crabs that you can see, that is in oxypodidal families, especially fiddler crabs, are so much tsunamis. So most of the scientists are telling that is Euchar, Ostracar, and then Delasimet like that, so much tsunamis can available. But in mangrove area, oxypodidal crabs, especially Annulippus, is very common in mangrove area. And then another one is the Portunic crabs. Portunic crab is that is distinctive character is interorbital distance broader, and then the 4 to 9 anterolateral teeth, and then very distinctive character is pig leg is has the paddle shape, and then Portunic crabs have 35 species, 10 genera. So this one is the family Porcunidae. Porcunidae are especially Coelosauridae. Genus Zilla is very common, and then very important for economics. And then this crab also serves best varieties also that we can eat. And then another one is the xanthic crabs. over 500 species in over 100 genera, and known as the corallo crabs and mud crabs, pebble crabs, or rubble crabs. And then their carapace is the hexagonal to transversely oval, broader than long, and then brightly colored and are highly poisonous, containing toxins that they are not destroying by cooking. And then anterolateral margin convex. Then they have black tips in their pincer. So they are showing that is so much poison. And then that is their family, the Thydid. This crab is especially in their forms on the near the shoreline area. And then another crab is the Gagacinix crabs. Their carapace is circular shaped, transversely ovate. 6 species in 5 genera, and then the dorsal carapace is smooth and then strongly convex, longitudinally and transversely. And then legs are stout, and then dactylates, especially longitudinal ridge that you can see. That is a family Cacasinidae, Catysoma. So this genus Catysoma, why? Could it be that is a heart? Soma is a body. So their body is a heart shape. So that's why it's the genus Catysoma. So this figure shows that is the distributions in different habitats of mangrove. This figure shows that you can see, especially in Abyssinian zone, mangrove crabs are more diverse than others. Why? Because most of the crabs are taking Abyssinian leaves. So that's why it's Abyssinia zone that you can find so many crabs species and diverse than other zones. And then, sir, what is biodiversity? Biodiversity is the burying or reworking of soil sediments, which bring up the previously buried sediments. So scientists are telling that is a mangrove crabs are ecosystem engineer, the best ecosystem engineer. Why? Because crabs are burying. This burying activity can become biodiversity process. So biodiversity process is this everything is cause and effect. So biodiversity is first digging the soil. This process includes crabs are digging the soil. Due to digging the soil layer and upper soils are missing. So the aerating the soil coming. Aerating the soil that can cause microbial activity more and more. Due to microbial activity is more and more, that can be accelerated through litter decomposition. This litter decomposition is more higher and higher level that can cause their release of nutrients higher level. So much high level of nutrients can release in mangrove ecosystem, the times phytoplankton and zooplankton are higher in mangrove ecosystem in coastal food web. In coastal food web, including and staying so many animals are staying, including crabs. These crabs are taking phytoplankton and other detritus matter. These crabs, after taking food, that time these crabs send out speckle plates. So these speckle plates are including nitrogen, so that can cause the defecation. These defecations process and then surfaces, and then the detritus are missing. That time detritus are feeders, especially including crabs also eaten. So that is a little life cycle is coming. And then another thing, biodiversity that can cause tidal flushing. So tidal flushing is that is the water moving in and out, water moving. Due to in and out water moving, that can cause toxic hydrogen sulfides and methane reduction and then salinity reduction. These effects can cause. So these effects can help to promote their mangrove growth. So another thing, nutrients release higher level in mangrove ecosystem, that time mangrove growth more rapidly within a short time. And then another, this process also due to later decomposition that can cause detritus more and more. So biodiversity process is very important. So that's why crabs are ecosystem engineers in mangrove. So biodiversity process. What is the benefits? Benefit is the alterations of nutrients and five sediments of alkaline water. And second, shelter to other species in burrow. Their burrowing activity, that time they can get shelter inside the burrow and then serve mating and then serve breeding. So many things can benefits can available, and then restructuring of sedimentary deposits with rich organic carbon, and then serve can transport sediments to and from, and then serve upper and lower layer sediments can transport. And another thing is the modifying sediment texture, and then accelerating nutrient cycling, especially carbon and nitrogen. And then, sir, this picture shows the taken measurements or baromorphology. This one is this work is recently my research work. So, how can you measure? How can you take measure for baromorphology of crabs? That is, sir, this baromorphology. First, if you want to take the baromorphology measurement, first you need to put plaster of Paris powder. This plaster or Paris powder and water is 2:1 ratio. You can mix. After mixing this ratio, plaster of Paris mixing, you can pour inside the barrel. So after 3 or 4 hours, that time, sir, this barrel is completely dry. After completing drying, you can dig out this barrel very carefully because it may be broken. And then so after digging this barrel, you can take measurement. That is the opening of the barrel diameter. You can measure from that side. And then sir, this one, you can measure total barrel depth from starting opening of the barrel diameter to the end of barrel. That is the total barrel length. And then total barrel depth is from here, opening of the barrel diameter to the depth. That is the barrel morphology of and russet crab that you can measure. Another thing, that is the main barrel length. Where is the main barrel length? Main barrel length is from here, from opening of the barrel diameter to here. That is the main barrel length. And then like that, that's here you can, that is main barrel length, that is the branch, sub branch like that. So many branch can also you can available. And then sir, you can calculate the bulk density, and then barrel volume like that. Sir, that depends on your idea that you can take measurements. And then sir, that you can see Alger UV and wine shapes and the vertical and complex of branching morphologies with a single entrance to complex or interconnected shops multiple entrance. So this barrel, that is the top mark part, barrel opening shaft. And then this one is this side is bottom mark part, barrel chamber. So barrel chamber is very important for the crab because female is always check quality of the barrel. If barrel quality is not good, that time this female won't accept male to mating, because why this female is not accept quality is not good barrow, because this female need to mate with male, and then after mating baby also will born inside the barrow. So family barrow, the whole family will stay inside the barrow. So that's why quality of barrow is very important. So female is always checking the quality of barrow. If female is not satisfying the barrow quality, she will come out immediately. Okay. That is the importance of crab barring in mangrove ecosystem. marine habits are held in nutrient recycling, aeration, and free circulation of water, which promotes the growth of seedlings on mangrove. Marine habits held in oxidizing the sulfide that build up due to high rate of organic decomposition in mangrove swamps. So, these figures show that is eukaryotes, eukaryote or ostracolytics economics, make the burrows and excavate soil in the form of soil ball. After ingesting fine particles, including microalgae, each species has distinct cloth movement and color differences. And then male are claimed, but when female is coming, that time this male fellow is his sign. That is waving sign for mating to female. Or yucca crabs that tolerant to hot temperature but not sea level rise. That is the tank. I'm keeping these crabs in the tank in my room. And then another thing is a very interesting feature, that is cannibalistic interrupting. Interrupting sometime. Okay. So the molted salt body being eaten by milk cooling into the barrel. And then said this figure showed eating and cooling into barrel. That is a molted female crab eaten by milk. So the importance of crabs in mangrove ecosystem. What is the importance? That is the degradation of mangrove leaf litter by seismic played a key role as a major link between primary and secondary producer. Crabs help in the breakdown of particulate organic matter less than 50 micron in size by exposing them to microbes. And then species of crabs that contain nitrogen, carbon, phosphorus, and trace metals to form rich food for other consumers. And then another medicinal values of crab is crab meat. That's called eosinophils and escar, which is a primary complex that stimulates the brain cell. And then another crab shell, suture threat, bodily effect, not allergic, dissolves in glucose and no scars. And it's an oxypodic for a good restorative after childbirth. And then another socio-cultural value is Romans worship. The crab seeds God in the name it is a Neptune, god of the sea. And then crab's caryatics is called as a symbol of cross-vine Christians living all over. So that is Christian crabs. And then another one is the Fortunate crab. These Fortunate crabs is that you can see three-eyed. So three-eyed god in areas, especially being worshipped by Hindus. Then, crabs consumption. Crab larvae are consumed by carnivores, thereby an important role in food chain. Crabs form the food for many birds, snakes, and predatory fishes. So crabs are consumed as food by many for delicacy. So may I say, no mangroves, no crabs, especially particular sesame eggs. So this photo